Another example of perception to help understand what the programming assignment is supposed to be doing. I think some of you are overthinking it. The first part, the perception algorithm, is actually very simple. You can easily do it in under 20, 25 lines of code in the right language, ignoring all the I/O stuff. So it shouldn't be very hard for you to do, but let's walk through an example in more detail. So in this example, here's an input file. First item on every line is the label. 1 says it's positive, 0 says it's 0 negative, and then the coordinates x, y. So this is a 2D example so you can visualize everything. I'm going to assume lambda equals 1. That's actually a pretty large value of lambda, but sometimes it'll work. It just makes it easier to follow the math here. We're going to start with an initial W of all zeros. It's actually not a very good value because it even doesn't properly define a line or in 2D. It should be some random value, but again, just so you can follow along. So if I look at my first sample, 1 minus 2 minus 2, I'm going to get an x of 1 minus 2 minus 2. The 1 here is not the input file. 1 is the first item of all values for x. When I do w.x, I get 0. It's supposed to be a positive value because there's a 1 for the x class, so I know that's wrong. So we're going to update w. W is going to take its old value plus, in this case, the positive label, so I'm going to say plus 1 minus 2, 2. That gives me a new value of w of 1 minus 2, 2. So that's a line that has a slope whose normal is minus 2, 2. The normal is pointing that way. The line is, of course, perpendicular to the normal. And its distance from the origin should be 1 unit, which is about why it's about there. So that's W. Now, I should take these in random order, but I'll just follow along in order in the file. So in this case, I'll take my new x will be 1 minus 2 minus 3. The 1 is because it's an x, not because there's a 0 here. Right? I do the dot product, and for that dot product, I get 1, 4, minus 6. So I get, I said here actually minus 2, it should be minus 1 because there's 1 minus 4, so it would be minus 1. But that's correct. It should be negative. It starts with a 0. So it's fine. We leave the line alone. The next input is 1, 3, 2 if I'm doing them in order. I do that dot product, and now I get a wx of 1 minus 6, 4, so I get minus 1. That's wrong. You sort of see it graphically. It's on the wrong side of the line. So I'm going to update w, and again, in this case, because it's a positive thing, I'm just going to add it in. So I'm going to get w is 1 minus 2, 2 plus 1, 3, 2. So I get 2, 1, 4. That's going to turn the line significantly. I get a new line. If I go process my fourth point, 0 minus 1 minus 2, I get an x of 1 minus 1 minus 2. I do that dot product is minus 5. It's correct, and we leave w alone. I would normally just keep going until I've processed things, and so there's nothing going on. I might go back to the first sample. I test the first sample. I do the dot product. I find it's 8. It's correct. In fact, at this point, your algorithm can do a couple more random samples, but they're all correct, so the line will sort of stay there. So that's how simple the Perceptron algorithm really is. You really just keep randomly sampling points, use them weighted by lambda, although here lambda was 1, to adjust your weight vector, and that will eventually find the line if there is one. If there isn't a line, it'll run forever, so please make sure you have a finite value to your loop.